2,500 tickets will be sold for a raffle at a cost of $2 each, and there is only one winner who gets $1,000. What is the fair price to pay for a ticket, and what is the expected value for playing this raffle? All right, so we know that there's only actually, well, there's two outcomes here, right? So because there's only one winner, okay, which means that that one winner will get $1,000. Okay, so we're going to put the payout here in the first column. We're going to put the probability of that payout happening in the second column, right? So, okay, the winner gets $1,000 or everyone else doesn't really get anything, right? Because there's only one winner here. Right, so this probability is 1 out of 2,500. Okay, and the probability of winning nothing, right? Well, there's 2,499 essentially losing tickets, right? So you notice that I did not account for the $2 here into the payout, okay? So this is one way to calculate this, okay? So if we don't take the $2 into account, right, that's called the fair price. So what happens here, right? Let's multiply these out. And I'm not going to convert this to a decimal just yet. So we get 1,000 over 2,500. And then for the bottom one here, well, it's just times 0, right? So we get 0. And when we add these together, we do just get 1,000 or 2,500. So now using your calculators, we can get this as 0.40, right? So this is actually the fair price. Okay? Okay. So how can we get the expected value then? Okay, well, if we take the fair price, okay, minus the cost to play the game, okay, you know, usually in casino games or gambling games, there's like some upfront cost, right, or some payment. So minus the cost to pay, so 40 cents minus that $2, that gives us $1.60, right, negative, right? So that's going to be the expected value here, okay? So what does that tell us, right? It tells us that if each ticket cost 40 cents instead of $2, right? If each ticket cost 40 cents, okay, that will be the fair price, okay? Now let's think about that. If there's 2,500 tickets and each ticket costs 40 cents, right, then that would be $1,000 essentially, right? That's $1,000 revenue coming in. Okay, but then, hey, wait a minute, there's a winner who gets $1,000, right? So essentially, this raffle comes out even, right? They don't make money, they don't lose money. Okay? But because of the cost, right? Because this game does cost $2, right? Essentially, every ticket will lose $1.60. That is expected value because that's over the long run. Okay? Now, there is another way to calculate the expected value. And what I'm going to do here is I'm going to make the same table, okay, with the payout and the probability. Now, once again, there's just 2 in this case, right? So I'm only making 2 rows here. But I'm going to take that $2 into account, right? So, okay, the winner gets $1,000, but they paid $2 for that ticket, right? So they're going to gain $998. Right? But then what about everyone else, right? They're going to lose $2, okay? And of course, that probability is still the same. There's 2,499 losing tickets. Okay, so now let's take a look. What happens when we multiply these out, right? Well, 998 times 1 gives us 998 over 2,500. 2 times 2,499 gives us negative 4,998 over 2,500. And you notice when we add these together, right, 998 minus 4,998, that's negative 4,000 over 2,500. Divide these, we get negative 1.6. Okay? Look at that. That is the expected value. So if you take the upfront payment or the price to play together with the payout, okay, then that calculation does give you the expected value straight up. Okay? But as you can see here, right, we did not take that price to play into account. Okay, so that would just be the fair price. Okay, so to get the expected value, there's 2 ways to do this.